Hi guys, so today we're going to be talking about relations and functions. Prior to any of the examples, please make sure you also look through a lot of your vocab words you should be familiar with, such as quadrants. Relation is your domain as your x coordinates, your range as your y coordinates. What a function is, where every element of the domain only has one element of the range, mapping, and what a one-to-one function is. Okay. So here we're going to start off with example 1. We're going to state the domain and range of the relation shown in the graph and then determine whether or not it is a function. Okay, so the domain is all of your x values. So here your domain, we're going to list them in order. So the first one is here at -4, 3, so the x value is -4. The next one I see here is -1, -2, so -1 is the x value. This one here is 0, -4, 0. Then the next one here is 2. And then the last one here is 3, -3, so that's a 3. Okay, so that's all of their x values here. The range is all of the y values. So starting with the bottom, which is the lowest, that's -4 at 0, -4. Next one is -3 for 3, -3. There's a -2, but there's -1, -2, and then the last one here, both of them are a 3. Okay. Is the relation a function? Yes, it is a function, because every x value only goes with one y value. The x values never repeat, and so therefore it is a function. Okay. So why don't you try check your progress 1, and then once you have that, check your answer. This is what you should have gotten. If you got it, move on to the next example. If not, here it is. The domain, the x values for these coordinates is -2. This one is 0, 1, and 3. -2 appears twice, but we're not going to write it twice. We just write it once. Okay. The range, the y values are -4 here, 0, 2, 3, and 4. This is not a function because of these 2 points, -2, 2, and -2, -4. Note they share an x value. Okay. This -2 goes with a 2, but this -2 goes with a -4. And because the x values repeat, it is not a function. Okay. Example 2 here, the table shows the population of the state of Kentucky over the last several decades. Graph this information and determine whether it represents a function, and then also is the relation discrete or continuous. I just included the graph that the book already did. All they did was 1960 3.0, so 60 3.0, 1970 3.2, 1980 3.7, 1990 3.7, 2000 4.0. Okay, this is a function because the x values, which are the years, doesn't repeat. Okay, here they also wanted to introduce to you the vertical line test. You should be familiar with it, but if you're not, the vertical line test tells us that if we take a vertical line and go across the graph, as long as our graph only touches the vertical line at one place at a time, then it is considered a function. Okay, it makes sense because a vertical line is x equals a number. So if it hits it more than once, that means that x value showed up more than once. Okay, so it is a function. Is the relation discrete or continuous? Since these are individual points that aren't connected, this is considered discrete. Okay. So you're going to try number 2 on your own. You're going to graph the information, decide whether it's a function, and then if it's discrete or continuous. Okay, here you go. You should have a graph similar to this. The x-axis is the year. The y-axis is the number of employees. I started here with 99, 0, 0, 1, 0, 2, 0, 3, 0, 4. And then because of space, I started at 25 and then made each box 1. Okay. So 1999 goes with 25, 2000 goes with 28, 2001 goes with 34, 2002 goes with 30, 31, 2003 goes to 27, and then 2004 goes to 29. Okay. It is a function. It does pass the vertical line test. Each year only has one number of employee number that goes with it, and it is discrete because it's not all connected. Okay, so there you go. So now let's move to example 3. We're going to graph each equation, find the domain and range, and then determine whether the equation is a function, and state whether it is discrete or continuous. Okay. So the first one here is y equals 2x plus 1. You should recognize it as a line. So we're just going to graph it like we graph lines. Okay. So here, since this is in slope-intercept form, I'm going to start with the y-intercept at 1. And then since the slope is 2, I'm going to go up to right 1, and then I could keep going, but technically I only need 2 points to graph any line, but just so that way it'll be nice. I'm going to connect it. Okay. And technically lines go on forever, so I'm going to put my arrows. Okay. So is this a function? Yes, it is. Passes the vertical line test. Each x value only has one y value that goes with this. And since this is a line and all the points are connected, this is continuous. Okay. Here, the next one, x equals y squared minus 2. Whenever you have something to graph that you don't know, like the rules of how you're graphing versus like for a line, you know, right? Slope, intercept and use slope, right? But if you arrive at something you're unfamiliar with, the best way is just to make a table. Okay. In this one, it's a little bit weird. The y value is actually your independent variable. So we're actually going to be plugging numbers for our y here. And then whenever I don't know what to plug in or which numbers to use, I generally, at least for now, start with -3, -2, -1, 0, 1, 2, and 3. So all I'm doing is plugging it in. So -3 squared is 9, 9 minus 2 is 7. I'm plugging in -2. -2 squared, that's -2 times -2, that's 4. 4 minus 2 is 2. -1 squared, so -1 times -1 is 1. 1 minus 2 is -1. 0, 0 squared is 0. 0 minus 2 is -2. Plugging in 1. 1 squared is 1. 1 minus 2 is -1. And then 2. 2 squared is 4. 4 minus 2 is 2. And then 3. 3 squared is 9. 9 minus 2 is 7. And now I'm going to graph these points. So 7, -3, 1, 2, 3, 4, 5, 6, 7, -3, 1, 2, 3. Okay. 2, -2. -1, -1. I have a, oh, do I know how to graph? Clearly not. This is not a point. Sorry. -1, -1 should be here. Next is -2, 0, that's here. Then I have -1, 1, that's here. 2, 2, that's here. And then 7, 3 is here. Okay. And technically I could have plugged in decimals and stuff as well. But because, you know, that would have made my life harder, I'm not going to, but I can imagine so. And then here, I'm gonna connect. Okay. Is this a function? This is not a function. It doesn't pass my vertical line test. And as you can see, my x values have repeated, right? 7, 7, 2, 2, -1, -1. So it's not a function because these x values go with different y values. Okay. However, it is continuous. Okay. And there you go. Okay. Next, you're going to try 3A on your own and then come and check your answer. Okay, this is your graph. Hopefully you could recognize that this is a quadratic function and know how to graph it. But if not, you just plug in values for x. Again, I generally do -3 to 3. Okay, plot the points. It should look like this. Your domain is all real numbers in interval notation that's written like this. Your range starts at 1 and then goes up towards infinity, so that's all numbers y is greater than or equal to 1, or all numbers from 1 to infinity, including the 1. Okay, these mean the same thing. This is just inequality, and this is just integral notation. Okay, it is continuous. They are all connected, and this is a function. Each x value only has one y value that goes with it. Okay. Okay. So last part here is evaluating a function. Okay. We're given the function f of x equals x squared plus 2. Hopefully by now you know f of x is just another way to say y. Okay. So starting with a, it asks for f of negative 3. And what you can see is f of x, f of negative 3, it looks the same. The only thing that changed was that negative 3 here has replaced where x was. So that's all you have to do. You're just going to have to replace wherever x is with negative 3. Right, so that's what I'm going to do. I'm going to plug in negative 3 in place of the x. Everything else should stay the same. Okay. Negative 3 squared is negative 3 times negative 3, so that's 9. Then 9 plus 2 is 11. So f of negative 3 is 11. Okay. Next, here you'll notice f of 3z. Okay. Note the only difference from here, f of x, and this f of 3z is that the x got replaced with the 3z. So that's what I'm going to do. I'm just going to replace the x with the 3z. 3z squared. 3 times 3 is 9. Z times z is z squared. Okay, so note how this looks different. Before, this squared went with the 3 and the z. Now here, this square only goes with the z. Okay, 9z squared plus 2, and there you go. Okay, so why don't you try 4a and 4b by yourself, and then come check your answer. Okay, you should have gotten negative 6.58 for 4a and 8a squared minus 20a plus 3.5. If you got that, you're good to go, ready to start on homework. If not, here's the explanation. Right? So here we're told that g of x is 0.5x squared minus 5x plus 3.5. Here with g of 2.8, all that happened is that the x got substituted with a 2.8. Okay, so then I'm just going to continue substituting the 2.8 for x. Okay, then all I'm going to do after that is order of operations. So starting with exponents, 2.8 squared is 7.84. Okay. Then it's multiplication, 0.5 times 7.84 is 3.92. Negative 5 times 2.8 is negative 14. Okay. Last is the addition subtraction. 3.92 minus 14 plus 3.5 is negative 6.5. Okay. Over here, g of 4a, all you can see is that the x got replaced with 4a, so I'm just going to continue replacing the x with 4a. Okay. After that, using order of operations to simplify, so this is exponents, so 4a quantity squared. Right, so 4 squared is 16, a squared is a squared. Right? Note the difference before this squared went with both the 4 and the a. Now here, the square only goes with the a. Right? After exponents comes multiplications, so 0.5 times 16a squared is 8a squared, right? Half of 16 is 8. Negative 5 times 4a is negative 20a, so 8a squared minus 20a plus 3.5. This is fully simplified. There are no more like terms. Okay? So that's it for today. Have a great rest of the day. Bye, guys.